Welcome to the Lineage University Art Gallery lecture series. We are very pleased to have today the lecture presentation about Santiago Calatrava early drawings 1980-1982. Before I start speaking, I think that did that much introduction among us. I would like to announce a couple programs. I was told by Norman Girardot to make sure to tell everybody that beauty and utility program, the colloquium, starting today with the Calatrava beauty and utility drawn together. And then in October 18th, the Wednesday will be faculty and staff student colloquium, building bridges together at 4:10 to 6 p.m. at Chandler Allman Auditorium. October 19th, which is a Thursday, rebar dedication, ritual and film vision. That will be also at the Chandler Allman, right behind Chandler Allman, but in case of rain, will be in Chandler Allman. And December 8th, Friday, last day, a terminal celebration and display of the Bridging Spirit. That will be at 4:30 to 6:30, and the location to be announced. Okay, now we go to our business, and we are very grateful to Tom Peters, Lehigh University Professor of Art and Architecture, Director of the Building and Architecture Technology Institute, and noted scholar of building technology, who have generously lent his private collection of Calatrava drawings for this one-of-a-kind exhibition. And today we go to hear Professor Peters talk about a group of early sketches by Santiago Calatrava. We'd like to welcome Tom Peters.
Thank you, Ricardo, and welcome. If we can dim these lights so that we can see the screen better, that would be good. Can I do it from up here, or? Oh, you're doing it. Thank you very much. Today, I'm going to explain the culture that formed the phenomenon that is Calatrava. I cannot, of course, explain how he gets his astonishing ideas. Nobody can do that. But I can only explain the unusual cultural background from which they arise. Bear with me, it'll take quite a while until I even mention his work, because the background on which it developed is broad and deep. Everything we build has a genealogy. Even the greatest works come from somewhere and relate somehow to the history of building. Man the creator, as opposed to the creator of the universe, never stands alone. Newton formulated it so clearly 4 centuries ago. He said that he was only able to see farther than others because he stood on the shoulders of giants. So a world filled with prototypes, models, and exemplars peeps from the shadow of every innovative structure. Behind some of Calatrava's amazing ideas in the little exhibit that you'll see upstairs stands the Gunter Bridge, and I'm trying to go forward here, stands the Gunter Bridge, built by his teacher Christian Menn in 1982. And behind that again stands Robert Maillart's Tabernaza Bridge of 1905, just turned upside down, as Menn once explained to me. This does not mean to say that there's no such thing as invention or genius. There is, indeed. But they are not what they seem to be from the outside. And the subtle shifts in thinking that a creator makes while designing or inventing are in truth far more complex and far more intriguing than an outsider might guess. There are different ways to accomplish such shifts in thinking, and they are characterized by different schools of thought. These schools determine how designers form their design logic and how they choose among the many possible design methods at their disposal, and how they give each decision they make weight and value in the design process. Values are created in the educational process, and they are transmitted from teacher to student. Switzerland has such a living tradition. It evolves from generation to generation, and it continues to generate interesting structures to this very day, in the works of Calatrava, but also of others who are as yet less well known, and they will be better known in the future. Now, Calatrava is not Swiss, but he chose at a young age to come to Switzerland to be educated in structural engineering and to study with Christian men, whom he considered to be one of the most admirable designers of his day. So he voluntarily adopted Swiss building culture, immersed himself in it, paired it with his native Catalan culture, and ultimately carried it one step further in a new direction, or maybe several steps further. To understand this development, we have to go back generations. Before the Industrial Revolution, all building activities were unified in a single profession, that of the master builder. With mechanization and industrialization in the 18th century came fragmentation and specialization, and a group of professions developed with often contradictory goals. Aesthetics versus structure, rationalization versus fantasy, making versus imagining. Switzerland is in this regard an unusual country. The Swiss pick and choose their influences from among the surrounding cultures of Germany, Italy, France, and Austria. And the country remained somewhat sheltered from the worst excesses of 19th century professional fragmentation. The founders of the Swiss Federal Institute of Technology, now called the ETH for short, were intrigued in the 1850s by the novel pedagogy developed at the École Centrale in Paris. The founders of that school were convinced that engineers had to be practical to serve society. This appealed to the pragmatic Swiss, and they stuck with the model even after the French themselves abandoned it later. As a result, structural engineers in Switzerland have always been closer to the pragmatism of the building site than in other countries, and architects have always been more solidly founded in technology than their peers elsewhere. Even today, Switzerland boasts the only professional organization that never split into an architectural and an engineering society. Of course, the two are distinct professions in Switzerland as elsewhere, but the ETH and the Swiss Engineers and Architects Union, SIA, provide more interface between these two than elsewhere. The fragmented transalpine country that is Switzerland presents severe structural challenges. The concentration of cultural, topological, and geological conditions in such a small space made the country into a melting pot for European technological culture. The line of small cross-cultural countries that leads from the Netherlands and Belgium in the northwest southward through Luxembourg, Lotharingia, Alsatia, Switzerland, Liechtenstein, and Tyrol to Friuli in the southeast, forms a fruitful cultural seam zone that runs right through Europe. And Switzerland at the middle of this chain was large and independent enough to form its own multicultural and multilinguistic unit within this zone. Now, I stress the issue of language because the peculiarities of a language influence our ability to form abstract concepts. Let me give you an example. The German words Platte and Scheibe do not correspond exactly to our English terms plate and slab, although they may derive from the same root. The German terms describe the structural behavior of planar structural elements. The Platte resists out-of-plane forces. Here, forces from outside the plane in bending, and the Scheibe resists in-plane forces and accommodates them through shear. The English terms, in contrast, describe spatial orientation and construction, but not how the plate and the slab work structurally. The lack of preordained orientation in German explains how the engineer Robert Maillard, a pioneer in reinforced concrete construction whose mother tongue was German, created his novel bridge forms. His language made it easier for him to envision planes that took either bending or shear and lay obliquely and freely in space. Had he thought in English, the development of such structures may have been much more difficult to conceive. Not only that, but the need in tiny Switzerland to translate technological and design thoughts between the national languages, and there are 4 of them, fosters a conceptual flexibility. Another part of this culture were the theoreticians and teachers. Karl Kuhlmann and his student and successor, Wilhelm Ritter. They contributed to the generation of a Swiss school of thought by connecting the visually based engineering tradition in pre-industrial society to the new analytically based engineering tradition of the technological world. Kuhlmann founded the building department at the ETH in 1854 that taught both fields, architecture and engineering. Behind him, and off to the right here, stood Jean-Rodolphe Perronnet, another Swiss, who had opened the first academic engineering program in the world that was founded in France in 1747. Kuhlmann, on the left there, created graphic statics, a form of analysis that is based on vectors and that made the mathematically abstract developments in French analytical engineering that were anathema to most practicing engineers at the time into forms that were useful for practitioners. Ritter then expanded Kuhlmann's theories and made them even more visually accessible. Ritter and Kuhlmann together developed a unique translation between abstract analysis that is expressed in mathematics and visual design that is expressed in form. And this translation still characterizes the Swiss culture of thinking in engineering today. 3 generations of directors of the National Institute for Testing Materials, the EMPA, followed them and strengthened the practical connection by the full-scale load testing of novel structures that they developed for the designers. Especially the third one on the right there, Mirko Roche, perfected empirical testing methods for novel and theoretically complex structures, like the monolithic reinforced concrete bridges of Robert Maillard, who you see at the bottom there with him, and many others whose names remain less known, although their works are equally fascinating. An important ally was the editor of the Swiss building journal, the Schweizerische Bauzeitung. Together, the practitioner Maillard, here, the theoretician and tester Roche, and this publicist, whose name was Werner Jaeger, stressed the pragmatic over the merely theoretical, and showed that the new bridges worked even though theory could not prove that they would be able to stand at the time. They forced even the most adamant skeptics to accept the new developments. David Billington at Princeton has studied some of these men, especially Maillard and Ritter, but much work still remains to be done to clarify the development of this unique way of thinking about building. There's yet one more leg that the Swiss school of thought stands on, and that is the special character of the Swiss building code. From the very outset, in the code of 1892, that came into being in reaction to a dramatic railway bridge collapse, this code has always been a set of recommendations enacted by the SIA, by the National Professional Organization, not a law, the way it is, for instance, in Germany, France, or the US. So the code in Switzerland is not law, it's recommendation. And professionals may therefore, at any time, step outside the code and take personal responsibility for the safety of their structures, something that we cannot do in the United States and that no other country can do. Insurance covers them in case of mishap, but Switzerland being so small, no professional reputation can survive a serious mistake. Ostracism and certain financial ruin accompany any professional irresponsibility. So instead of legal limits, social limits make sure that engineers are very sure of what they're proposing to build. This fosters, of course, conservatism among the less daring. But it also fosters innovation among the bold. And the National Institute for Testing Materials goes along with it even today. A particular characteristic of the Swiss school of thought is visual thinking. Kohlmann and Ritter started it, and Ritter educated two great 20th century practitioners, Robert Maillard, whose works we've already seen, and Ottmar Ammann. The first three directors of the National Testing Laboratory supported it, and 20th century educators continued it. In particular, Pierre Lardy underscored the importance of structural form, beautiful form that the engineers could live with and they could be proud of in his lectures. And he influenced two further builders, Heinz Isler, who you see on the right, and Christian Menn on the left. Possibly a third, Heinz Bosdorf, who also came under his influence, and a fourth, Hans Haury, a theoretician, my own teacher, worked as an educator whose strength lay in making the flow of forces visible in models, and this was particularly useful to his many architecture students, me included. Now, Isler still works as a builder and an experimentalist on his own. He's 86 now. Actually, no, he's only 80. He's young. And he creates new structural types, as you can see here. He is so bubble-generated, thin concrete shell domes have become famous, something that no builder in any other country dares do because the codes don't allow it. But he stepped outside the codes and proved that it's not only possible but also beautiful. Here, the Kilcher shell in Recherswil in Switzerland, or the simple gas station at Deitingen, which was recently placed on the National Register of Historic Structures. Isler bases his design method on the careful measurement of models corrected by visual perception and his structural and construction experience. So it's not only theory, it's not only form, it's not only experience, it's all three together that make these forms and condition them. Christian Menn, Calatrava's teacher, communicates his thinking through his own built works and through those of the next generation he teaches. In particular, the engineers you've never heard of. Come on, move. Your concept here and Calatrava, who you have heard of. The connection between structure and form as a hallmark of Swiss design gained historical perspective and fame through the admiration for the bridges of Ottmar Ammann in the United States, which was publicized by the theoretician Fritz Stüssy in Switzerland and Max Bill, the sculptor and architect. And Bill and Siegfried Gideon worked on Maillart's pioneering concrete work and published it and made it famous as well. Especially Bill and Gideon spread this awareness internationally, and that led to the celebrated exhibition on the modern movement and its aesthetics, particularly with regard to Switzerland, at the Museum of Modern Art in 1949, and later to the influential writings of David Billington. The many supporters of Swiss thinking stressed the work of a select group of Swiss engineers, and especially bridge builders, and interpreted the development as an inevitable and positivist force that, of course, it isn't at all. From this public relations burst came an awareness of a lineage and an interest in understanding and using what others had thought and done before. There are, of course, many, many more participants in the Swiss school of thought than those shown here. And they're not all of them Swiss. Calatrava isn't Swiss, I'm not Swiss. Many are not Swiss. But there are many more participants in this school of thought than those who are shown on this image, who developed design thinking in many different directions. Now, the Swiss themselves find this simplification a little bit suspect, and they tend to downplay the role of individual engineering structures and people. Maybe this is due to the fact that many still knew the people who designed them personally, or perhaps because the stress placed on single objects neglects other, less obvious, and yet equivalently qualified works. The list of others besides the well-known Maillart, Men, and Calatrava would mean nothing here, but it's long, and the works they built are equally worthy of closer examination. Swiss engineers recognize that a too radical simplification of history tends to stress results, and it neglects the process of problem solving that lies behind a school of thought. But it's precisely the intellectual characteristics of the thought process that constitute the central qualities of a school of thinking. And yet, although the Swiss downplay the role of those who others may consider to be heroes, the awareness of the uniqueness of their thinking permeated the culture, and over the years, a forceful method developed that found expression in the curricula of engineering and architecture programs. Emigration of qualified professionals from the small country carried this culture out into the world. Coleman, the founder of the school, consulted for the railways in Turkey at the end of the 19th century. Ammann, the bridge builder, and the dam builder Alfred Nötzli, one of the forgotten innovators, worked in the United States. And of course, Ammann built the biggest bridges in and around New York. Maillart worked in Russia for many years, until the revolution forced him out. Heinz Hausdorff, also ignored until recently, I'm sure you've never heard the name before, worked in Spain. And Calatrava, whom you have heard of, works around the world. By no means does this signify that everything good in building comes from Switzerland. Don't misunderstand me. But it does document a curiously intense contribution from so small a country. I mean, the country is about the size of Pennsylvania. That's all. The ability to develop novel and technologically appropriate structures is not limited to any one culture, Swiss or otherwise. And other forces exist that influence the development too. It's a little bit too short today to detail them all, but Spain, France, Mexico, the United States, Germany, Denmark, Russia have have all contributed dramatically to the development of structural form. But one of the strengths of the Swiss tradition lies in the need for flexibility, to resist a creep toward the ossification of thought in a canonical system. The private nature of the codes is both a reflection of this need and one of the vehicles by which it is implemented. Swiss educators and engineers realize that a tradition can only serve innovation if it remains flexible. Maillard and Amann developed approaches to design, and the next generation, Christian men, Heinz Hausdorff and Heinz Isler, drove them further. Now there's a new generation, particularly visible in the work of Santiago Calatrava and your concept that carry this work forward. Each succeeding generation introduces new ideas and concepts. Their unifying commonality is the adherence to the idea of the relationship between structure and form, the respect for the value of historical thought processes, not history, but historical thought processes, and the conviction that large and small-scale problems are both formally relevant to a design. And those of you who study architecture here realize that obviously our chairman, Tony Viscardi, comes from the same tradition. He was trained by one of these people in VPI in Virginia that carried this and brought it into the United States. In the case of the current generation, Jörg Concept uses erection processes and materials as his intellectual basis. He often explores composite structure, in which different materials play differing structural roles. In this, Concept stays squarely within the framework of engineering and architectural tradition. The Traversina Bridge, a lightweight wood and steel wire structure, had to be flown to the site by helicopter. Early American truss bridges lie conceptually behind this structure. Concept's strength lies in his knowledge of materials and what they can do structurally. Transforming forms and contrasting materials play a big role in Concept's design strategy. The Suramsunds Bridge, suspension bridge, explores local granite as a compression member and stainless steel as the tensile member in a post-tensioned tension ribbon bridge. So this pulls and this is pushed together to create this structure. So he's built this bridge out of compressed concrete as a tension structure, which sounds like a contradiction, but here it is. It works. And it is Heinz Hausdorff's curious proposal for a post-tension granite bridge in 1950 that consciously lies behind this. The Peidenbad Bridge combines wood and concrete, with the wood serving as false work for pouring the concrete, as formwork in other words for pouring the concrete, and a way to stabilize the lightweight concrete deck laterally. And the deck serves as weather protection for the wood underneath. Here, the pre-industrial bridge structures of Hans Ulrich Grubenmann, a Swiss master carpenter of the 18th century, underlie this design. A comparison of the details of both bridges demonstrates the relationship pretty obviously. And Concept admits this. He talks about this when he explains what he was doing. In Calatrava's case, quite different. Human or animal anatomy and the illusion of movement, or in some cases actual movement, serve as basis for his design. Transformable geometries are a logical consequence of this interest, and he has transformed them into many interesting structures, like this garage door in the Ernsting warehouse in Germany. In fact, he actually reinvented the garage door in a certain way. Movement and transformation have led Calatrava to concern himself with unstable equilibrium as well. And this, in turn, has generated such interesting projects as his current design for a skyscraper in New York City, which isn't built yet, it may be, or the fascinating sculptures that were the subject of his recent exhibition at the Metropolitan Museum, also in New York, or to dynamic-seeming buildings like the Turning Torso, recently completed in Malmö in Sweden, or his proposal for the world's tallest building in Chicago, also a project that hasn't yet been built, and may be. So this issue of anatomy, movement, transformable geometry, and unstable equilibrium have informed and continue to inform all these projects. Very different from concept, very different from his teacher Men, very different from his ancestor Maillard, but very much in the same mode of thinking, the same school of thought, with different things brought in from elsewhere. Unlike concept, Calatrava uses architecture and engineering as vehicles for emotional expression that go beyond tradition. While on the one hand, this earns him accolades from laymen and critics who are fascinated with the Baroque idea of the Gesamtkunstwerk, the total art expression. Others look somewhat askance at his lack of economy in what he does as an interesting excursion into art, and regard it as being entirely without longevity in the field of building. After all, building is tied to the creation of functioning objects for human use, and the issue of economy, whether economy of material, erection, manufacturing effort, or money, is important in the creation of our built environment. And this can again be countered by referring to Gothic and Baroque church architecture, where the emotional content of extremely expensive structures contributed to their function as religious edifices. And it is true that Calatrava himself is inspired by the work of Antoni Gaudí, the Catalan architect whose masterwork, the Sagrada Familia Cathedral in Barcelona, is still incomplete after a century under construction. So on the one hand, economy means a lot in building. Calatrava doesn't take this into account at all, but there is a tradition for the lack of economy in building as well. Transformation and contrast play as big a role in Calatrava's design strategy as they do for concept. As an example here is the Oberbaum Bridge over the Spree in Berlin. The midspan of this 19th century brick bridge, of no particular interest really, was demolished as an element in East Germany's wall around West Berlin. Calatrava tried to commemorate that act of destruction by replacing the missing span with a new and different steel segment that demonstrates that break, that demonstrates that destruction. The forms for this replacement that he built, of course, come from his Swiss background, and there's the genealogy of them, from Maillard to Men to Calatrava. But his concern with the symbolic meaning of his design, above and beyond the function of the new span, are entirely his. The exhibit upstairs comprises only about a dozen sketches. Let's move. Next slide, come on. We're not moving here. So, the exhibition upstairs. It's only a dozen sketches, but they're rarely seen early sketches, and they show both where Calatrava comes from and the promise of where he would go as a mature professional. The small, double-sided sketch for entrance instance here that is so easy to overlook shows his first idea for a folded plate roof structure that would appear 3 years later after the sketch in the Jacken factory in Münchwilen in Switzerland. The even earlier proposal for a new bridge to replace the K bridge over the Limmat in Zurich, and this may very well be Calatrava's earliest documented independent design, drawn in July 1980, shows a cross-section, that highlighted area there, that would resurface 13 years later in the Kronprinzen Bridge in Berlin, that you see up there. The even earlier, the next one is the dancing heads, as I call them, derived, of course, from Christian Men's Gunter Bridge. They come back 22 years later, transformed into his twisting torso building in Malmö in 2002. Now, an important characteristic of any school of thought is not only the transmission of form from a master's early works to his later works, but the transmission of knowledge and experience from teacher to student. Menn explains his surprising design for the Gunter Bridge of 1981 as a simple inversion of Maillart's innovative design for the Tavanasa Bridge in 1905. Of course, that's not how he designed it, but that is how he explains it to others. And Calatrava also refers back to his intellectual grandfather Maillart, with his sketch of the 1933 Schwantbach Bridge that is also exhibited upstairs. Then Calatrava goes on to modify and expand on his own teacher's bridge in an exploration of the formal potential that the idea suggested to him. Calatrava is both an architect and an engineer. He comes both from the formal side of design as well as from the structural. This is another version of what Kuhlmann and Ritter did and began a century and a half ago when they related the analytical approach to engineering that was new at the time, the mathematically explicable approach, to the visual approach of actual building. Calatrava does this in a different way, fully aware of this tradition that lies behind it. The relationship between teacher and student, however, is a two-way street. And Menn reacted to Calatrava's sketches with a few hasty drawings of his own in 1982, trying to improve on what he had done. So what he was doing here was thinking that by splitting these apart up here and not putting these in concrete, he could show the layperson how tension was pulled back into the pier. By articulating the cross-section of his, this one is fading on me, of his pier here, he could show the layperson that maybe it was hollow inside. By forming a little shadow here, by indenting the bridge, at that point, he could show that this box, this hollow box, wasn't that thick, it was only this thick. So all of this were thoughts that Menn had when he did these sketches. And they were obviously in reaction to what his young student had done at the time. In fact, in 1979 at a conference, Menn was giving a lecture on his new bridge, and everybody was surprised by it and amazed by it at the time. Showed images of the drawings that are upstairs and more, saying a young student of his had done this in reaction to his design, and he was fascinated by the formal possibilities in it. So here he was, talking about his student and his reaction. Here is Menn's own reaction to what his student had done. Then later, in his design for the Suniberg Bridge over the Langfahrt in 1999, Menn very clearly refers to Calatrava's sketch proposal for a three-pier bridge that you'll see upstairs. So this was a hypothetical sketch that Calatrava had done in reaction to what his teacher was doing, and this is the teacher's reaction years later to the sketch that his student had done. And when we compare the piers of the Gunter Bridge on the left in 1982 to those of the Sunniberg Bridge in 1999, 17 years later, we can see how men's own ideas developed over the 17 years and what they owe to his students' work. Of course, the work, the implementation, and the design are men's own. He's not a copycat. He's an innovative thinker and a designer, as much so as his student has become. And men went on to expand these ideas into a three-dimensional pier configuration for his latest masterpiece, the Zakim Bridge over the Charles River in Boston, that was finished in 2002. So here he turns this two-dimensional cable organization and pier, holding them back, into a three-dimensional pier and cable configuration in his newest bridge. Let's hope that men, who is now in his mid-80s, will continue continue his innovative work for another 10 to 15 years maybe, to show us where these ideas can lead us next. Calatrava, with his very different design agenda, took the same idea, the pier with the tension members pulling it over, and continued to examine unstable equilibrium, his fascination, in the Alamillo Bridge over the Guadalquivir in Sevilla in 1992. The interaction of ideas between these two master bridge builders from two generations show us how a school of thought functions. Its mutual influence and creative exploration into new directions. But the story is far from over, and so we can only look forward to what may come next. Thank you. I will be glad to take questions or protests or whatever. Very glad. As you can see, I am part of this tradition, was educated, as was Tony Viscardi here, educated in the same tradition. So maybe, Tony, you can say a few things to this too.
It's amazing to see the work and to see the evolution of thought. It actually reinforces the fact that a lot of that stuff did influence me to some kind of through Olivia Ferrari and Trevor Cronin.
Of course. And I'd love to see a couple of your sketches that are currently being exhibited in Buffalo up here with them to show where this thinking can move and how it spreads around the world. I mean, it's not confined to that little country the size of Pennsylvania, lost in the mountains of Europe at all. It just was generated there.
How old was Calatrava when he went to Switzerland?
Let's see, in his early 20s.
So he did his early schooling in Spain.
He studied architecture in Valencia, and then did these experiments with these flapping structures and these expandable structures. And
Those were in the 80s?
those were done in the mid-70s in Spain. And then he obviously, as you can see from those results, had the feeling that his teachers in Spain in architecture couldn't teach him enough. He needed more. And he needed more solid stuff about materials and building and equilibrium, how these things stand up. So the people in his own culture were dead. I mean, Torojo was dead. Candela was in Mexico and old. He wasn't building anymore. And Gaudí had long been dead. So where did he look? He looked for where Torojo had learned from, Maillard, and found that there was a follower of Maillard in Switzerland who was teaching at the ETH in Zurich. So he stormed his office. He stormed his office as a young student, hardly speaking any English or German at the time, and came and chatted men up and said, "I'm coming to study with you, I don't care." And men, of course, were fascinated by this young Spaniard who very politely sort of stormed his office and said, I'm coming to study with you. Excuse me. I'm here. Make of it what you will. I'm going to learn from you. And he did. And he did. And the relationship between these two, of course, very forceful personalities, has been somewhat difficult over the years, but you can see how each learned from the other and continue to learn from the other. The 80-year-old from the 50-year-old, the 50-year-old from the 80-year-old. And that is only symbolic because I'm talking about Calatrava because the sketches are up there. I could talk about Concet in the same way, and you saw that his structures were fascinating. And there are others who were part of the same generation, who are doing things I don't even know about, who I'll discover in the future, and will be happy to discover. And older people who are now gone, whose works have been forgotten. Who has heard of Alfred Nötzli anyway? He built the first shell dams in the United States. In other words, dams that don't resist by their sheer weight, but resist by their form. Again, he was trained in Switzerland, the issue of form and structure. And he came to the United States and built these dams, and among dam builders his name is vaguely remembered. But Amman is much more known because his bridges are visible and there for everybody to see, whether it's the Verrazano-Narrows, the George Washington, the Lyon Bridge, the Throg's Neck, and so on and so forth, all these bridges that are known in New York that he built. Nötzli is unknown, but just as important. Sarrazin, just as important. Also a name that not even if I mention these names in Switzerland are they known. People haven't got a clue. They're forgotten, they're long gone, but what they did, their thinking, and that of course can inspire us in design for our thinking. What we do is still there for those who look at it. Sorry, I can continue. I just go on and on and on. I love this stuff. Yes, sure.
Can you talk about your personal relationship with Trump and how you acquired these drawings?
Oh, well, he was a student when I was an instructor at the ETH. And he was doing his master's with men, and we became friends, and I forget how that exactly happened. But I was very fascinated with him and his work and his sketches at the time. And I helped him a little bit while he was being desperate during his dissertation and so on. And sort of invited him over for dinner. And you could never know with Calatrava. I mean, being a genius, he's just out of control. You never knew whether he and his girlfriend, Tina, would come for dinner when they were invited, or tomorrow or yesterday. They just turned up, or didn't. And but if you could accept that, you had a wonderful time with them, and we did. And he was appreciative of that at the time, somebody who would help him and was interested in what he was doing and fascinated him. Most people were intimidated. I mean, he was so forceful and so abrasive about what he did. He considered most of his professors absolute schmucks. To tell you the truth, compared to what he could do and did and has done. Not men, not a number of them, but most of them. And he was completely intolerant of fools and said so, to their face. And so, of course, that doesn't make you awfully popular. And so somebody who could take that and enjoy it, as I would, became a friend. And so we became friends. His birthday is one day before mine. And on my birthday, July 29th, 1982, he walked into our apartment, which we were repainting and remodeling, taped these sketches up on the wall, kissed me on both cheeks, wished me a happy birthday, and walked out. I said, stay for a glass of champagne, will you? He said, no, I have no time. I've got to go to work. Well, he was. That's the story of those drawings. Just happened. And of course, I'm glad to share them with you.
We are very happy to have them.
Well, I'm
Part
happy
of
that
it,
they
you've
enjoy.
gotten interest from other people to see.
Yes, they have been a lot of interest and a lot of people coming, architects from Philadelphia who just come to see it, and from New York, and
They wanted
tremendous amount.
they wanted to travel.
Well, we are now doing a feasibility study of that definitely, they already have made some inquiry about that.
Yeah, there's been interest from Madrid and from London as well. I might not have them on my wall sometimes they come. I don't know. I like to share these things. They're so nice.
Another thing, Tom, that you refer to and is very strong on Calatrava is the visual thinking, you know, how he used anatomy and things, you know, I mean, and actually he transformed. I mean, that piece that we have from Sunday morning news, and you know, they show some of his work in Milwaukee. They actually talk about how he, you know, the picturing idea, you know, how he
One of
actually.
these key things, and as I think it was Mark who pointed it out to me, there's this question mark in there. There really is.
Yeah.
I haven't shown that to Calatrava yet, and I will. But when I see him, in 1982, that was actually a little note card that he attached to a copy of his dissertation when he handed it to me. And I took it out, thank God. A student then stole the dissertation, that's gone. But I have the copy, and it's upstairs. It may be one of the earliest doves that he drew, but Clotilde and I, my wife and I, looked at this when we opened it and said, oh my God, Matisse couldn't do it any better. And he was completely unknown at the time.
Picasso,
or well, I'm a great fan of Matisse. Sorry, but couldn't have done it any better. And at the time, Calatrava was unknown. I mean, how hubristic is that for an unknown student? You look at this and say, well, Matisse, Picasso.
Well, he talks about, you know, how he actually learned and referred to the human figure in a lot of it, because they are asking, for example, in the Milwaukee, you know, I mean, how the whole.
Well, a lot of that is hokey. He does the design first, and then he invents the animal to go with it afterwards. So, I mean, you know, sometimes it works one way, sometimes it works the other way. He does things for public relations too.
Of course.
So. But it's very genuine. I mean, the relationship is very genuine. But what comes first, sometimes one, sometimes the other. Don't always believe the explanations that you are given by the people. Some of it is public relations issues.
Yeah, the whole thing about light that he's doing in the transportation center.
Oh yeah,
That is a very.
Oh yeah.
And you can see a lot of that forms in the drawings. You know, all that being recycled. You know, it's a tremendous.
Well, I have a lot of slides that he himself made that, of course, I haven't shown here, of the dog skeleton that he has on his table, where the repetition of the ribs and the bones and the structures have inspired it. I mean, it's not for no reason that he has this skeleton on his working table. And it's part of his way of looking at things.
Was he a bit of a collector?
No.
Not like you.
Not like me.
Question for me.
I just wondering if you could say a little bit about the distinction between form and structure. Some bridges you say work by structure, others work by form.
No, that's not what I say at all.
So just something about the distinction between form and structure.
No. When you
seem to be
come
operating with
to
such
a
distinction.
design, you can come from the structural side, you can come from the formal side. And particularly in the work of that fellow who designed these very thin soap bubble shells, some of them quite remarkable and quite surprising, that he proceeds from model experimentation, where he measures the model, he blows soap bubbles up, and then he photographs them and measures them, you know, dimensions. And then he creates these in concrete. But before he creates them in concrete, he puts them through the computer and analyzes them, and then he looks at the analysis and he corrects the analysis with visual perception. This is right or this is not right.
So would that be form or structure?
Both. He comes at one visually and he comes at the other analytically. And it's two sides
So they're really
of
one
design. Well, the design is one thing. And it's two different approaches. One an analytical, abstract one, and one a visual one that's far more complex to understand. Visual perception. That you know what is right and not right. How can you even explain that? It's very difficult to explain, if at all possible. And that's why these grumpy-looking directors of the Materials Testing Institute, otherwise a thoroughly boring topic, right? Certainly not visual, played such an important role because they realized that by load testing these things and eyeballing them, they could help these designers make structures that nobody could calculate, that everybody was afraid would collapse. And their work in testing these, both in model and in the finished structure, the theoreticians then caught up later on. But they helped this creative process, realizing that not everything is explicable in analysis. Maybe analysis will catch up with it later, but analysis is only a tool. It's not design. And that's what they realized. So that you can come at it analytically, you can come at it visually. And it's the interaction of these two things that form the exciting issue that is this so innovative and creative design process. Sorry, I tend to go on forever. Let's call it a day.
Well, you know,
I'd be glad